Considering the economic future, so you think that we're going to be looking at an asteroid in, say, 15 years? Most likely?
You know, right now, it's a real challenge to do that mission with the funding profile that we have. And so, you know, we're going to take small steps on the way there, and it might end up being more than 15 years. But I think that eventually we will get there. And then, of course, you never know what the future holds. For example, there's an asteroid that looks like it might have the potential for contacting Earth, you know, in the 2040 time frame. If that turns out to be more real than we think, then that could turn up the funding and the techniques that we're developing now for work on asteroids and reacting against them and all that. All of those techniques will be applicable to understanding asteroids better in the planetary defense sense. That, you know, if it really, and don't misquote me here, you know, statistically, it is a certainty that the Earth will get hit by an asteroid again someday. It might be 50 years or it might be 100 million years. But the fact that that's going to happen means that we need to be thinking out ahead and working out the techniques where we can slightly alter the course of the asteroid far enough away that we avoid, you know, direct hit.
So, I'm sorry, one more question. Somebody mentioned that the astronauts who were down on this crew probably wouldn't be still in the program to do an asteroid, but that really doesn't matter.
It doesn't matter. I mean, all of us are attacking this like we're the crew that's going to go there, and you know, we're putting that kind of enthusiasm and meticulousness into it, so that if we go, it's great. If we don't, then somebody like us will go. And, yeah, I always have my fingers crossed. These asteroid missions are long, and you get a high radiation dose, so it favors the older people because there's a limit on the lifetime cancer risk from radiation. So you never know. It's probably, you know, not super likely that this crew or me or anybody will actually go there, but I wouldn't rule it out. And it doesn't change our attitude with respect to how we approach this work one way or the other.
Oh, cool. Yeah, okay, done. How fast is an asteroid moving? I mean, it's probably ranges. Probably some move. What would the range be? I guess.
So there's two velocities that matter. One is they're orbiting the sun, and that's typically 6 years. And of course, we would match their speed, so there's no relative motion once we're there. But the other element that's important operationally is some of them, if not a lot of them, are actually spinning about an axis, and that spin rate can be an operational factor.
Sure.
So back at the Johnson Space Center, we have this full high-fidelity asteroid SEM that is projected on a screen in front of the SEV that we're living in, and we're actually flying that, and we're able to investigate the effects of different spin rates on our workload to maintain station, on the prop usage, and so forth. And what it looks like is at 2-hour spin rates, we're pretty fine. I mean, it's not that hard. And then
2 hours for one revolution?
Yeah.
When you say that? Okay, yeah.
As you get faster than that, it gets harder and harder to work. And then, of course, the characteristics of the asteroid will affect their spin rate. For example, if it's a loose rubble pile, at certain spin rates, that would just impart escape velocity to all the elements of it, and it wouldn't be a congealed mass. Other ones that are so-called monolithic, that might be like iron, nickel, or something, they could spin fast because they wouldn't fall apart. So, but we're very systematically understanding the effect of spin rate on our operations, on the workload, and the prop usage.
Okay. Yeah.
And then the other part of this is that the asteroids are orbiting the sun.
I said 6 years. So, but can you turn that into a speed? Like, how far?
It depends on what the circumference of the orbit is.
Oh,
So
right.
I don't have that on the top of my head.
Right. I mean, they're like like 50 miles an hour, or like 200 miles an hour,
No,
or like
way more than that.
way what?
Way more than that.
Oh, okay.
Thousands. Of
Oh,
miles.
thousands of miles an hour. Okay, yeah.
But that doesn't mean much if you match the rates with.
Right.
I mean, for example, the shuttle, we orbit the Earth at 17,600 miles an hour, and we rendezvous with satellites and grapple them, and the relative speed between us and the satellite is nil. So, but the bigger part of the speed is that we have to get out to the asteroid, ride with it for a while, but leave it with enough prop to get back to the Earth. So if we stayed there, for 3 months or something, you would get so far from the Earth that you couldn't get back. So
Sure.
there's a limited window based on the propellant we have that enables us to rendezvous with the asteroid, perform some ops for 2 to maybe 4 weeks, and then get back home.
Right.